Hey there, hope you're doing well. In the last video, we talked a little bit about performance and scalability with just a high-level introduction to the topic in itself. And I mentioned that in the next one, in the subsequent one, which is this video, I'll talk, we'll try to dig deeper into each of these aspects when it comes to the performance and scalability of your systems, right? So let's talk about performance first and then we'll go to scalability. Just to recap, there are differences, there's similarities between them, but they are quite different from each other. Performance is how your system performs when even when a single user is using it, and scalability is when how does that performance extend or extrapolate when more people start using the system and it comes to humans, and the same thing is applicable to non-human requests, right? System to system requests as well. So okay, let's start with performance. Let's take an example. Let's say you're going to a page as a user, you're not that performing, but you're doing a certain action. You click a button and then the page changes, right? Or that aspect, that part of the page changes to return your results, right? Let's say you're going to an employee roster. You want to see a list of employees, so you say show employees and then shows you a list of employees or something like that, right? Or it could be a list of restaurants. Now, when you make that request, and it's very simple, I'm going to trivialize a lot of this in the interest of getting the message across. It could be an n-tiered application, it could be 2-tiered, 3-tiered, whatever, right? However your architecture is. At the highest level, you can think of it as you're on the browser, you're reacting on the browser, the request goes to your web or application servers, no matter how many hops there are in between. It makes a lot of difference, but let's say there are not that many hops. Eventually it goes to the database, it runs some queries and gets the list of restaurants back. All cool so far, right? That works just fine. Let's say you get the request in under a couple hundred milliseconds and you're happy. Now, what happens if you go to the next page and you do some other action and then you come back to the previous page again and then you see the list of restaurants. Now, there's many things that can happen here. One is whatever happened previously, the first time you were there, the same thing could happen all over again. It goes through all of the tiers all the way through and then gets a response back and maybe nothing changed and then you would see the exact same list of restaurants, but then you had so many requests and hops in between, it added literally zero value. And you might have a hunch as to where I'm leading with this. I'm not trying to propose a solution. So no, I'm not trying to think caching. I'm just trying to say that it's possible that the same actions can cause the same, can trigger the same sort of events, eventually resulting in the same outcome. So you can solve these types of problems in n number of ways. But what I want you to understand from that part of what I said is it did not add any value, right? The restaurant list did not change, but everything happened all over again. And then you come back and it took the same 200 or 300 milliseconds, which is just fine. Now, let's say another user starts making the same request, right? Or even before we go to the second user, let's say the same user does some other action and it triggers a sequence of events, and one of that, as part of that sequence, one of the queries that ended up being run was fetching the list of restaurants. Since I don't have a great example, it might seem a little bit convoluted, but I'm just trying to make the impression that the queries are not mutually exclusive from each other, right? Not all the time. So the same set of queries that may have been run previously, let's say you ran 3 or 4 different queries to get the list of restaurants. One of those queries could get executed when you're performing a different action as well, right? It does not have to be fetching restaurants. Maybe you're fetching employees in a restaurant, but then for whatever reason you had to fetch all the restaurants or some weird example like that. What that means is even for a single user, the same type of queries or the same queries may get repeated over and over again. That's futile, right? It doesn't add any value necessarily, and that's going to add to your performance issues. So what's going to happen is where you needed to run one query, you ran 2 or 3, or you may need to run 3 if you don't already have the results for one of them. But if you did have the results for one of these other queries, then running that again does not provide any meaningful value. And those are types of things that can affect the performance of your system from a single user standpoint. Now let's keep that in mind. And sometimes when you draw this out, it's a whole lot easier. I have a way to do it, but for whatever reason, I sometimes don't consider that when I'm doing these videos. So when you go to scalability, let's introduce a second user who's performing the same actions. at the same instant of time, or around around the same window of time. So we would have executed the restaurant query once for the first user, and then the first user did something else within the next 30 seconds. We ran that query one more time, and then the second user also ended up executing the same query. And let's make some assumptions with ceteris paribus conditions. Let's assume that they belong to the same organization, they have the same access, same type of role, so they are seeing the same content. Right now, that's not the case, things will change, but let's make those assumptions. Now, when you introduce a second user, they end up resulting in the execution of that same query the first time, and 30 seconds later they do something else which results in that restaurant's query being executed one more time. So now that same query got executed like 4 times, right? We're just talking, there's various aspects to performance optimizations. It's as interesting as any other topic when it comes to software engineering. But to keep a video focused to the extent that I can, I'm just focusing on a tiny aspect of it, and I'm talking about databases and queries here, right? So essentially, we're talking about the execution of the same query 4 times. And sure, the database has its own kinds of optimizations, but that is also a separate topic. How the database is going to optimize queries, whether you can pin them to the database cache, and depending on whether you're using RDBMS or NoSQL, which database you're using, a lot of them bring a lot of differences and nuances to the table. Each of them is obviously a large topic, but let's say the database did or did not do the optimizations, or didn't do it to the extent that you wanted for it to have done it. 4 queries would have gotten executed in that same window of time. Now that means whatever else somebody else was doing in the system, maybe there was a third user or a fourth user, and they may have done something entirely differently from requesting the list of restaurants. But even so, even that being the case, now your database is actively processing these 4 queries. Sure, it doesn't mean it can only process 4, but whatever it could do, it's got 4. It can do 4 less now because those queries were processed repeatedly. So when the third user is doing some unrelated action, they're also at the mercy of that lag from a database performance standpoint. So the scalability will get impacted, because even though the 300 milliseconds was all right for one user, when you added the second user into the mix and then the third, now the 300 might become 350 or 400 or 500 or maybe 600, which means it degraded like a whole 100%, right? Which is terrible, because even though these numbers might seem small, it's generally death by 1,000 cuts. When you add all of them together, the system is going to it's going to become much slower, and it may not just scale at all. So how you want to address these problems depends on what you identify as the bottlenecks in these systems, right? There's a certain amount of research that you have to do before you get to the bottom of it. But that's the cure, right? Prevention is always better than the cure. So when you design and architect newer systems, you don't have to over-engineer, but just try to ask yourselves, hey, what might be the bottlenecks in the application that I'm starting out to build? Because the chain is only as strong as the weakest link, right? We all know that. So you want to make sure that the weakest link is not weaker than what your systems and your requirements can actually accommodate, because different people have different levels of tolerance. I've actually changed services because something took 2 minutes to either took a minute to log in, or a minute is a stretch, but let's say it took 7 seconds or 10 seconds to log in, or each action maneuvering through the pages took 3 seconds. I'm like, if I have a choice, I'm actually switching providers, right? And for the same reason, every time we implement a feature at Snowball for our product, we take a lot of pain and effort to making sure that the performance stays good and it's also scalable as we continue to grow. And we did not talk about a variety of different solutions, whether it's software or hardware solutions, what's cheaper, what's not, and when it comes to these optimizations. I'll just pick them up from a subsequent video, but I think it's important, just if you forget everything else, just remember that how you optimize each of these is different. Performance can be optimized differently than scalability. But more often than not, I've seen that you want to improve performance before you improve scalability. Now, there might be cases where you're okay with the performance, even if it's not great. You just want to make it more scalable. And when it comes to cloud computing, it's actually, you can do it n number of ways, right, without touching the core components or your code base at all. But that's a topic for another day. Thanks for watching, and by the way, don't forget to download the Snowball app. Thanks.
Ooh. Beep boop.